We're going to continue dealing with slope. This is a special case of slope and rate of change called direct variation. Direct variation, for two variables x and y, they vary directly if there's some number k such that y equals k times x. Hopefully we can tell that this looks like y equals mx, where m is the slope, because k is going to work in much the same way. K is called, in this case, the constant of variation. This equation, y equals kx, is in slope-intercept form with a y-intercept of 0. Direct variation equations always have a y-intercept of 0. It's always y equals kx. There can never be plus anything or minus anything on the outside there. That can't happen. And as we just said above, k we can also think of as the slope, which we've dealt with already. So what do these look like and what are they? If we look at the examples on the left, if we want to find the constant of variation and the slope for this first equation, y equals 2x, k equals 2, and the slope is 2. That's the same in both of these. Typo on my part, I forgot the y equals on that last one down there. But anyway, the k in this one is 1/2, and the slope is also 1/2. So hopefully we see that those are always going to be the same. The number in front of x, just as before, was the slope. It is now also referred to as k for direct variation. The other type of question that you'll see takes a little bit more work, might be slightly more difficult, but it's still very, very workable for all of us. If we look at x and y, we know they vary directly. When x equals 5 and y equals 20, it wants us to write an equation to model this. So we want to use our y is equal to kx, because we have to find k first. So I have y is 20, k we're looking for, and x is 5. So if I solve this by dividing both sides by 5, still same rules that we've done before, the inverse of multiplying by 5 is dividing by 5, I get 4 is equal to k. So that puts my equation as y is equal to 4x. That is the direct variation equation given that x equals 5 and y equals 20. Oftentimes, once you have found your direct variation equation, you'll be asked to evaluate it for a particular value of x. So as this follow-up question states, it should say, what is y when x equals 10? So we have y equals 4 times 10, which hopefully we all know is 40. So when x is 10 in this case, y would be 40. So again, those are the types of questions that we're typically going to see. Here's one more example. X and y vary directly when x equals 4 and y equals 24. We want to write an equation that relates x and y. So for these, we start with our equation, y equals kx. Well, y is 24, k we don't know, x is 4. The inverse of multiplying by 4 is dividing by 4. 24 divided by 4 is 6. So we get k equals 6. So we want to write our direct variation equation will be y is equal to 6x. Right there, y equals 6x. And now we're asked to find what is y when x equals negative 5. That's our follow-up question. Y is equal to 6 times negative 5, which is negative 30. That's all we'd have to do for the direct variation equations. We'll get into some applications and some more practice of this tomorrow, but this is all you have for your homework this evening. We'll see you tomorrow.